Okay, so right here we discuss ordinary annuity, and we just get back to time value of money. Ordinary annuity is a series of payment that is at a fixed amount occurred every period. Okay, and the payment is made at the end of each period. Annuity basically means same amount every period. Ordinary basically means it's paid at the end of each period. Like your car loans, like your mortgage for house, like your credit card bills. These are all the cash flows which you borrow first, receive money today, and then you get it paid back at each of month or each of year. If the payment is made at the beginning of each period, then it's called annuity due. Okay, it's a different name, annuity due. Still, it's called annuity because a fixed amount of payment every period. Okay, it's called annuity due because it's due at the beginning of each period. So the examples would be my cell phone bill, like I pay AT&T the bill at the beginning of each month. I pay my assessment fee to the homeowner association at the beginning of each month, and also you probably pay your rent at the beginning of each month instead of at the end. Another example would be annuity or the pension fund if you retire. That has to be at the beginning of each month because you have to rely on that payment to live for the rest of the month, otherwise you would be starved to death. So here is an example for annuity due, which the payment is made at the beginning of each period. Alright, so you just won the lottery and you get $50,000 a year. The first is paid immediately. Okay, so you don't have to wait until the year end to get the money, and you're going to receive 20 of them. The lottery company may claim this is a 1 million lottery because it's 50,000 times 20, but really you should look at the present value of this series of cash flows. If you use your calculator, and this is what you should do, alright, you set up n equals to 20, I equals to 8, and the present value is what you need to solve. So let me just repeat my process. Okay, so I just delete this whole thing, okay, and leave it at 0. And your payment is $50,000 occurred each year. And the really thing I want to stress is the selection of a method. Okay, you can hit end, you can hit begin. In your calculator, it's not just about putting right arrow or left arrow. Okay, so if you select one item, make sure you hit enter. Okay, right here after I hit this enter, end is selected. And then if I want to select begin, I not only need to move right, okay, make sure begin is highlighted, okay, but also I have to follow by hitting enter. Okay, that way begin is selected. If I move to the right, to the left, then if I do not hit enter, still leave as begin. And then I move up, okay, all the way to solve for the present value. I want to know how much this 20 payments will be worth. Okay, so alpha solve. Okay, so that's the present value or the total worth at today's dollar. That's $530,000. Okay, that's way below $500,000. So that's annuity due, which is pretty easy. I just added at the end of the chapter. What I really want to add it is called a shifted annuity. So this slide is just a regular ordinary annuity. That's a piece of cake, so I'm gonna skip that one. So shift annuity basically means your annuity does not occur until later. Okay, your annuity does not occur until later. Right here you see an example. All right, you see an example. So you have you are planning for your retirement, and during your retirement you want to receive $125,000 at the beginning of each year. Okay, at the beginning of each year, $125,000, and you have 30 years until retirement, and you want to spend another 35 years during retirement and waiting to die. All right, so these are the rate before retirement and during retirement, and you want to first solve for how much money you should have when you retire. Okay, at the moment you retire, at the moment you quit your job, you want to know how much money you should have. Okay, so you can plan for your future. All right, and afterward you need to figure out annual investment required. You can skip this one, skip this investment required today, just to figure out the annual investment required, which is the payment at the end. Okay, so as I mentioned earlier, when you retire, when you rely on a pension fund, the payment should be made at the beginning of each period, otherwise you will be starving to die. Okay, and if you save, when you work and you save toward retirement, you have to wait at the end of each pay period, because that's when you get your money. Before you get your check, you cannot save any money. All right, so the first annuity you need to solve is actually the later time period when you retire. Okay, when you after you retire. So if I go to your calculator, okay, let me just minimize them so we can see all of them at once. Okay, so what I want to put for the payment is 125,000. Okay, I want to receive this much money when I retire, and I want to receive that for 35 years. Okay, 35 years, and the rate of return during retirement is 6%. So that means if I keep withdrawing $125,000 each year, I still have some leftovers in my pool, in my bank account, and that money will still earn interest for me at 6% each year. All right, and then I want to solve for how much money do I need. So that's the present value I want to solve. Okay, I want to know at the beginning of my retirement how much money I would have. So that's the present value, and I have a 0 for future value, and the payment method is highlighted as begin. So then I would I would solve for present value, alpha, enter. Okay, so I'm going to need $1.9 million roughly in my bank account, so I can enjoy my life during retirement and receive $125,000 each year for 35 years. Okay, at 1.9 million is how much money I should have. All right, and basically this is a solved saving required at retirement. And the investment required today is skipped. You don't have to do that. So basically that asks you how much money do you need to invest today, and put it in a bank for 30 years so you can get 1.9 million. It just doesn't make sense because you're not having that amount of big money today and do nothing for the rest of 30 years to get 1.9 million ending balance. Okay, it's just not realistic. But you can try. You can try to find investment required today on your own. All right. So what I really want to focus here is annual investment required. So how much do I need to save each year to build toward 1.9 million ending balance? Okay, that's a question. So let's say you just start working and you want to save a certain amount of money. Definitely you are solving for payment, right? You are solving for payment, and you have 30 years to go. Okay, and each year you have a interest of 8%. And today you are not saving any money. You are not saving any money today. You just make a contribution through annual payment. So you're gonna leave a 0 for the present value. For the future value, it is going to be exactly 1.9 million because that's how much you are saving toward. So I'm going to copy this number underneath. So it's 1921017. So oops, 19,210,1. If you round it, it's going to be 18. All right. So the present value for the retirement is the future value for the period of working. Okay. And then I'm going to have a 0 for the present value. Okay. This is the working time period, the 30 years from now until you retire. Okay, that's a different time period. So the 1.9 is a future value now, it's not present value. And then you solve for the payment. You hit alpha, enter. So that's your answer. Each year you need to contribute $15,000 and 701 to get 1.9 million ending balance. Okay, so that's how you plan for your retirement. And this kind of question would be extra credit question in your exam if it is asked. Okay, but the required knowledge is you should know the difference between ordinary annuity and annuity due. So when the payment is made at the beginning of each period, you should be able to solve for the factor being asked.